Okay, awesome. So the title of the project that my students are working on is Modeling Energy Exchange at the Ocean-Atmosphere Interface. Initially, during the summer session, the investigation was going to focus on the local interaction between the air and the pond water and uh, measuring temperature, looking at temperature changes. But several things have happened since the summer. One of the things that happened is after the GLOW program, I went out to Caltech, California, to their Satellites in Education conference, and they set up a new project for us to work on with students, looking at aerosols and the effect of aerosols, either locally or globally. And then of course, we got struck by Hurricane Sandy here in New Jersey. We're back in October. So my project kind of evolved into more of a global scenario. Let me just, okay, advance here. What's going on? Okay, there we go. Okay, so about me, I'm not going to go through the whole list here, but I've been teaching for 14 years. Nesta Eastern Region Director, I've been serving that for about a year. Data Stream, I've been involved with AMS Data Stream for a long time, and I was recognized on different occasions. State Teacher of the Year back in 2010, and I was able to go out to the AMS annual conference and was recognized as a distinguished educator. So it was really great to be involved in these things and to be recognized for the work that I've been doing. Here's a school, Burlington County Institute of Technology. This is a satellite view of our school using Google Earth. And a little bit about the school. The school, it's a CTE school, trade school. So there's different career majors that students take up: auto mechanics, culinary arts, auto body, horticulture, a number of different things, drafting, arts. So there's different things that students are involved with in terms of career majors. So when they take a science, it's really they're taking a science as a requisite, of course, to a requirement to graduate. Many of the students are not going into science or engineering. They have these trades. They come into the school. They know what they want to do. So, of course, my objective as all teachers is try to make what we're doing relevant to what we're teaching. So the thought behind the project is to understand and model climate, and this requires a fundamental understanding of energy conservation within the Earth system and the energy exchanges that take place between the subsystems. So some essential questions that students are looking to answer is questions such as how is ground observations made, and then how is remote sensing data collected, how is this data modeled by scientists, how can models be used to describe systems, Earth systems, and how can models be improved. And so my kids, and by the way, they're physics kids. I teach geospatial technologies, earth science, and physics. So the physics kids are actually involved in this program right now. So the actual project that they're working on is approximating the internal energy of a tropical cyclone using satellite imagery, specifically Hurricane Sandy. So as I mentioned, Hurricane Sandy struck was a great opportunity to talk a little. I wanted to shift my project to Hurricane Sandy. And so the discussion first began with solar radiation and heating, looking at, first, there's the Sun-Earth system. Weather is because of the energy coming from the sun. The sun interacts with different surfaces, land surface, sea surfaces. And so there's different changes in terms of changes in temperature, the way surfaces respond to that radiation. So this is essentially then where GLOBE came into play with this program. So GLOBE played a major role in the very beginning, the very start of this, because I wanted the kids to start looking at looking at surfaces, looking at how sunlight hits the surface, how it responds, which surfaces, what materials absorb heat, absorb light, heat up, what materials don't absorb as well. So by using the GLOBE protocol, students were able to compare changes in temperature for different surfaces across several days. GLOBE protocol is used for surface temperature measurements, air temperature, cloud observations. This is the field data that the students were collecting. We used the infrared thermometer to make the measurements, and so students measured changes in temperature with white concrete, asphalt, as you can see, short grass out in the field there, ponds, pond water. And they made these, they would go out there, as we get out there as much as we can, weather permitting, and of course that that nothing comes up where kids have to stay inside. Try to get them out there as much as possible. Again, depending upon the weather, but we were able to get out there a good number of times. And then of course came the data analysis. We take the information, we bring it inside, we use spreadsheets to look at the data that we collected. We modeled the data using something called ImageJ, which is an application program to analyze images, to measure distances in an image, to measure areas, things like that. And then and these are some of the results that the kids got. So Gerard and I were kind of sharing data back and forth. For our school, these are the graphs that the kids were able to come up with, looking at temperature versus days for short grass, looking at concrete, looking at water, looking at asphalt. And as you can see, what the kids, of course, discovered was the fact that water takes a lot of energy for water to change, just a little bit in temperature, because of course we know water has a high specific heat. This is what Gerard, for his students, his data looks something similar to this. Very similar results, especially if you're looking at the water. Very little change in temperature. And so then, so one way, of course, students in terms of analyzing data is getting the kids to plot line graphs. That's one way that we can analyze data or model data. So I'm going to use the word modeling data, which is part of one of the objectives I want the kids to realize is how to model this data. Another way of modeling this data was using bar graphs. So getting the kids to make bar graphs and compare the different things that way. And as you notice, the title of the graphs is change in temperature. So whereas we looked at the actual temperature measurements on the line graph, these bar graphs look at change in temperatures for the various days. And then Gerard, their students made observations at 9 and 3 o'clock. And Gerard, with Gerard's data, I try to match up the days he got out to the days that I got out. It was difficult because sometimes he got out on days that I couldn't get out, and vice versa. So when looking at both data, try to match them up and look for similarities. So bar graph is great for looking at differential temperature. Kids go from a bar graph to looking, going back to a line graph and plotting the same change in temperature with the line graph, and something becomes very more obvious than the bar graph, and CIT day 4, there was convergence of those 3 materials, where the differentials were very similar. And looking at Gerard's data, one of his days had a very, very similar convergence. So again, we get in that kind of convergence. You know, what was it about the air temperature that day? What was it about cloud cover that day? So, you know, they start to probe these ideas, probe these questions. So again, you know, looking at, you know, whereas the bar graph, you know, it displays the data one way, models the data one way. The line graph models it differently, and where you cannot see a pattern in one model, you can maybe see the pattern in a different model. Air temperature was the one that changed the minimum. Again, it takes a lot of energy to absorb water. Water becomes the heat source for weather activity, such as you know, in ocean. So before we can actually investigate oceans, the idea was to then apply specific heat to, you know, students were able to measure the area of the ponds. We got the average depth of the pond. We found the volume of the pond. Known density. We got the mass. We plugged it into the heat equation, and we can come up with the amount of energy that the pond either lost or gained depending upon its temperature change. So the idea was what the kids found is that, you know, you talk about a lot of joules of energy with very little change in temperature. And they use image J to do this, to actually measure the area of the pond. So from here, you know, going from ground observations to remote sensing, the idea at this point is to, okay, so the kids, they make the local observations. They look at the field, they look at the pond water, they make those local observations. Now we take that knowledge, we take what we did with modeling data, using the equations, and now we get into remote sensing. We expand it out globally, and we start to see similarities between the changes in temperatures that the kids found with the pond to global patterns of surface warming through remote sensing. And then we get into ideas like, well, you know, what affects the amount of solar radiation that interacts with the land, with the oceans, and so we get into ideas of you know, latitude change, you know, things of that nature that affect sea surface temperatures. Again, local to global. So the idea going from the ponds, you know, making those local observations in pseudo data, collecting it, and then going globally with remote sensing. So that's the point I want to kind of, in terms of the technology point to get across, is going from the global, or rather, sorry, let me back up, going from ground observations and scaling up to global observations through remote sensing. And the ideas, concepts, the laws that govern energy, the energy exchange through the subsystems affect all levels. It goes through all levels. So now that we're dealing with global, the stage became set for the next part of the investigation, which is now we look at hurricanes. Now we look at the energy exchange between the ocean and the atmosphere, and that's like the next part of the investigation. The third part of the investigation is looking at hurricane intensity through aerosols, and, you know, how do aerosols affect storm intensity. And so this is a multi-part project. You know, as teachers, when we're involved with different things where it involves a student project, sometimes we have to try to fit one project into many areas as possible. So this I had to adjust this a little bit so I can fit this project into multiple programs. Again, using the GLOBE protocols was vital in the first part of the investigation, starting with those local observations, and now we're working with the more global aspects of climate, and that's the other thing too, that because the next part of the investigation, after we look at energies of hurricanes,
I'm not sure why it's not working on here. I'm going to make it again.
By 1 degree. what additional energy is now available to a storm? Can storms become more intense?
Still nothing.
So again, they start to make those connections.
Bob's been eating over there.
And that's it. I'd like to thank everyone. If you guys have any questions, cool. Thank you.
Volume all the way up. Checking your volume right there, and also your computer volume.